All right. Let's now talk about the different scales of temperature that are in use. What are the common scales of temperature? There are two main scales of temperature for measuring temperature. What are they? On one scale, called the Celsius scale, the arbitrary temperature, namely the temperature at which ice melts at atmospheric pressure, is chosen as its zero. On Celsius scale, 0 degrees Celsius is the temperature at which ice melts. Now, 0 degrees Celsius correspond to the level of mercury or level of alcohol when the bulb is surrounded by melting ice. On the other scale, called the Kelvin scale, use the temperature at which the molecular energy is absolutely zero. In other words, the internal energy of the molecules is absolutely zero. If you can reach that state, that will correspond to 0 Kelvin, the Kelvin scale. So, in order to reach that, you got to go down a lot from 0 degrees Celsius. At 0 degrees Celsius, the internal energy of the object is a very high value. In order to reach a stage where the internal energy is zero, or the kinetic energy of vibration or translation of the object is zero, you've got to go way down over here, and that is what we call 0 Kelvin. So 0 Kelvin is the temperature at which the molecules are absolutely at rest. Now, in the Celsius scale, the temperature is measured in a unit called the degrees Celsius. And on the Kelvin scale, it is measured as Kelvin. Now, this is something sometimes students and even professionals misuse. I have seen bulbs written with maximum temperature 800 degree Kelvin. Now, you don't call Kelvins degrees. When temperature is measured in Celsius, we call it degrees Celsius. But when you measure in Kelvin, you will simply call it Kelvin. So can you tell me, 0 degrees Celsius is how many Kelvin? If this is 0 Kelvin, well, I haven't given you the relationship. I will talk to that in a minute. We will use lowercase t to represent temperature in Celsius and uppercase t to represent temperature on Kelvin scale. And the relation between Kelvin temperature in Kelvin and temperature in degrees Celsius is this. T Kelvin is T degrees Celsius plus 273.15. That means from 0 Kelvin, you got to increase the temperature by 273 to reach 0 degrees Celsius. Now, one important thing you must understand is that each interval in Celsius and Kelvin are the same. So that makes it very easy for us to handle. In order to convert Celsius to Kelvin, what all we need to do is add that 273, this difference, and the temperature will then be in Kelvin. 0 degrees Celsius is 273.15 Kelvin. Most of you know this already. So this is 273.15 Kelvin. Now this is called the lower fixed point of the thermometer. What is the lower fixed point? It's the temperature corresponding to the melting of ice. The temperature corresponding to boiling of water is the upper fixed point. In the Celsius scale, it happens at 100 degrees Celsius. So 100 degrees Celsius is the boiling point of water at normal atmospheric pressure. And what is the corresponding temperature in Kelvin scale? In Kelvin scale, it will be 373.15. So most of these you know already, but keep these things in mind, very important as we go on. All right, mercury in glass thermometer. Let's spend a couple of minutes talking about it. Mercury in glass thermometers are used in the lab very often, and they are marked in degrees Celsius and use the property of expansion of mercury with temperature. I just showed you that. Well, that is an example of mercury in glass thermometer. The length of mercury column in the stem of the thermometer varies linearly with the temperature. You see, because the stem is very narrow, the increase in volume can be considered to be a linear increase. So we can say the length of the mercury column. Now I didn't say volume. You see, the increase in length of the mercury column is proportional to the increase in volume. So I can now measure the increase in length rather than the increase in volume. Now, two fixed points are marked on the stem. I talked about that already. What are the two fixed points? Well, one is called the lower fixed point. Lower fixed point is the temperature corresponding to melting ice. That means you cover the bulb of the thermometer in melting ice, and after the level settles down, make a good mark on the thermometer. That will be your lower fixed point. That will be 0 degrees Celsius. And similarly, if you cover the bulb in boiling water at 1 atmosphere, the level of mercury will increase and settle down somewhere here, and that will be the upper fixed point. The upper fixed point is the temperature corresponding to the boiling point of water. So you got a lower fixed point and an upper fixed point. In a Celsius thermometer, that interval between the lower and upper fixed points are divided into 100 equal parts. Now, if L0 is the length of the mercury column in the stem at 0 degrees Celsius, and L100 is its length at 100 degrees Celsius, and when you want to measure a particular temperature, if LT is the length of the mercury column at that temperature you want to measure, then we have a relationship connecting all those three quantities. Now this is L0, the length of the mercury column at 0 degrees Celsius. This length is L100, that is the length of the mercury column when the bulb is covered by boiling water. And suppose you want to measure the temperature of this water. What you need to do, put the thermometer bulb inside there, and suppose the level of mercury comes here. We will call it L sub T. Now, L0, L100, L sub T are all related, and we can now write a relationship like this. T degrees Celsius, the temperature corresponding to this length is T degrees Celsius, equal to LT minus L0 divided by L100 minus L0 multiplied by 100. That means if you can measure some of these quantities, we can calculate the unknown quantities. Is that right? All right, let's do a problem using that. The length of a column of mercury in a thermometer is 4 centimeters when it is immersed in ice water, which means this is your L0. And 24 centimeters when the thermometer is immersed in boiling water. This is your L100. What are we supposed to find? What is the length of the mercury column at 22 degrees Celsius? You need to find L sub T. Alright, let's do that. What do we know? We know L0 is 4 centimeter. We know L100 is 24 centimeter. We know the temperature that you want to measure is 22 degrees Celsius. Alright, we want to find the length of the mercury corresponding to that temperature. Alright? Okay, so this is L0, this is L100, and this is the level of mercury corresponding to 22 degrees Celsius. We want to find that length L sub T. Well, what all we need to do is come to our formula. We know T, we know L0, we know L100, we need to find L sub T. I don't think you need my help to do that. What all we need to do is replace all the unknowns by their values, solve for that L sub T. I'm going to leave it for you to solve. I solved it and I got 8.4 centimeter. So at 22 degrees Celsius, the length of the mercury column will be 8.4 centimeter. Let's now look at the B part. If the length of the mercury column is 25.4 centimeter when immersed in a chemical solution, what is the temperature of the solution? Now, obviously, if the level has to go above 24, the level of mercury is 25.4 when immersed in the chemical solution. You would expect the temperature to be higher than 100 degrees Celsius. Is that right? Well, we go back to that equation again. We now know L sub T is 25.4. L0 we know, don't we? L100 we know. We can now find the temperature by putting all these values. Our L0 is 4 centimeter, L100 is 24 centimeter, L sub T is 25.4. Bring all those values here, we get that temperature is 107 degrees Celsius. Okay, let's now